Joining me this morning. This one will be in English because my French you don't want to hear. I'm taking a little bit different an approach for this presentation. To introduce myself, my name is Tim Kitagawa. I am a field applications engineer with Microchip Technology. I've been in this role for about 20 years, and I cover most of Canada, so I've seen a lot of the technology and experienced the changes and growth we've seen over the last 20 years. I have not been with Microchip the entire time. I came to Microchip through an acquisition last year when Microchip bought Atmel. And so but we have very similar markets, so this is applicable to what I've been doing. I've also been covering Montreal in a lot of detail for the last number of years. I know the market quite well here. I work with all of the engineers and companies in using semiconductors in the Montreal area, and actually up into Quebec as well. So what I'm going to talk about today is what we're seeing with startups and the Internet of Things space. And some of my definitions, my viewpoints on it are very much opinions. So you may disagree, and I'm certainly open to having dialogue about that. So what is the IoT? So this is just a quick definition, and just for the purposes of the presentation. Basically, an object, a group of objects that send or receive data using the internet. It usually involves a remote location. It can be public or it can be private, so it doesn't have to be exposed to the whole world. And it generally involves a little bit more than just a machine-to-machine operation. Usually there's something that goes on outside of the two objects that are on the internet. And I would just like to highlight, too, that this is just one definition. If you talk to 10 different people, you'll get 10 different definitions. So there's not really any clear definition of what IoT is. So the other thing I want to talk about is startups, because this is, in my opinion, is what's really driving a lot of the IoT space. So a startup, again, for the purposes of this presentation, is a company that's existed for less than 5 years, pretty new into the marketplace. Has less than 50 employees, sometimes one. And is probably working on their first product. In other words, they don't have a lot of experience out in the market. Has revenue of less than $20 million. That applies to a lot of companies, but particularly with startups. They virtually have very little revenue, or perhaps none to speak of. Why would you do this? Why would you enter this IoT space if you're a startup? Well, for one thing, it tends to be young companies, people who want to explore their creativity. They want to do something new. A lot of the startup community is not really interested in going and working for a bricks and mortar company. They want to do something new. They're often young, or they're just wanting to explore the new world. They want to do something better. Young engineers have been exposed to technology throughout their life, and they live this. So they always are complaining about something they have that doesn't work properly, and they think they can do it better. For a new engineer, it's also a great learning opportunity. They've got very little risk ahead of them in the world. In my generation, we were all looking for a job out of university, get settled, go buy a house, have a family, that kind of thing. But young kids today don't necessarily want to do that. They want to go and learn more. They're not done when they finish school. They want to be their own boss, too. This is a fun thing to do. You've got very little risk involved. You've got very, very few liabilities. So they want to go out and be their own boss. And the interesting thing is that the IoT, according to some publications and statistics out there, 50% of the IoT innovation is going to come from companies that are less than 3 years old. And this basically puts them into that startup space. So a lot of what I'm going to talk about today is, as well, before I get to kind of the technology side of things, is kind of that mindset of where these startups come, help you understand, if you're interested in doing a startup, what you would do. But for those of us who've been working in the industry for a long time, to also understand that mental space where startups sit. So The other thing is there's been huge investment in startups. The investment community has put a lot of money into startups. Why? Well, return on investments in other industries hasn't been great for the last number of years. The market's been relatively flat, interest rates are low, that kind of thing. So they're looking for big pops where you can see explosive growth. And there's lots of investment money out there. So this is some older statistics into 2016, but showing that there's been a huge growth in investment into the startup world. And this is the hardware startups. And if you look at, all of the startups that have come out there, some of these I wouldn't call startups anymore. Some of them are. So, you've seen companies that have come out of Kickstarter programs and some venture capital investment and so on, which have been, very little companies that have become quite large ones. We look at the companies like Sonos there. You can go into any big box store today and find Sonos speakers and so on. And there's just a huge number out there. And this makes it exciting for startups as well, because they're saying, I could be the next one of these. Then we look at cities. So this is older data. So I believe this is from 2015. And the interesting thing from our market space is we see Montreal in there at about number 20. Unfortunately, Montreal has fallen off that because if you look at some of the newer data, you'll see that China has inserted a bunch of companies of cities like Beijing and Shanghai and so on are showing up in this, which have pushed Montreal out of it. But that doesn't mean that Montreal is not a great space for startups. There's an incredible amount of activity here. There's been a lot of investment we've seen into the AI space, for example, with some large companies coming and inserting money downtown. But this shows that, Montreal is a player, and it's exciting to be here, and we should understand this startup space because it's not the typical place where we expected, a lot of the advancement. The Nortels of the world are gone. So the R&D and the development is happening from these small companies. So it's quite exciting. So how do people, enter the world of startups? Well, the first thing they need to do is they need to get involved. Kids come out of school or have been working for a couple of years, and they want to kind of get together and find a group that works for them so that they can explore their ideas. So the first thing they do is they need to find others with similar interests, colleagues, friends. And then there's communities. These communities are happening, and as I talk to some, even the people today, there are things that we call meetups. And if you just spend some time with your search engine online, you can go and find these meetups in every city in North America. And people are meeting up not just for electronics or for software or specific projects in technology. It could be social stuff as well. But the startup community in terms of hardware and software and so on are also gravitating in these meetup areas. It gives you a chance to go and have discussions with other people with like interests to yours, and this is where ideas get formed or things evolve, and it's a good starting point. And so as an individual entering these places, you need to very focus in, find the people that make sense to you, find people with similar interests or perhaps complementary interests. Maybe there's a software engineer or a hardware engineer, but you need a business person as well. You need a marketing person. So all of those types of people can show up in the meetup community. And after, after the meetups, then we also have workspaces. And we see these in Montreal. I've been into some of these. So workspaces are locations where companies and people of all ages and size and companies of different sizes can get together. Anybody can be there, but you never know who else is going to be in this workspace, just like in the meetups. So you may find that you've got companies or players from large companies like the Ciscos of the world and the Googles who are actually in these facilities as well, because they're going to do some cool stuff. It may be their after-hours job. They may have their desk job in the day, and they're showing up in these workspaces to explore other things. So it's quite interesting that way. Then we move on to what we call incubators. And these are often run at the universities, but they can also be by local interest, municipalities, and so on. And we have some of these in Canada where cities are actually investing in space and providing places where they can further these small startup companies to help them move forward. They can also bring in, the incubators often provide a link to other possible sources to get people going. So if there's good ideas, they can help to move them forward by providing connections possibly to investors. You know, funding is often the next step after you have a great idea. Now you need somebody that's going to help you run with this and believe with you. These are generally less sophisticated than what I would call the more formal places, which we call accelerators. I've listed, by the way, some of these companies here. I apologize if I've missed you or some of these are out of date. It was just from a simple internet search I do. I do not spend much time with incubators personally, so this is just more just for your information, and some of the data I found off our local internet sites. And the last place that startups get their interest from is accelerators. So here's some lists of, again, some local accelerators. And these are driven, the difference here is these are driven by investors or people who really want to get access to these guys or girls with great ideas that have something to move forward. And they facilitate further development and advancing, as the word accelerate implies, to get people further into development, to marketing, to finding marketing and distribution strategies for how to get their products to market and actually see some revenue. So that's kind of the environment that the startups go through. So it's meeting people, finding a rich environment to develop your products, and then trying to reach out into the business world. And after that, we need to talk about how startups in the IoT deal with technology. And this is where I move a little bit into the business side of things because I get paid by a company. So I apologize if we go to a bit of the business side of things relative to my commercial interests. But again, this is fairly general. So, you know, then we have to move to technology in the IoT space. So this is the spectrum of what the IoT does. So if we go to the far left, there is some type of intelligent device that's on the edge of the internet. So sensing usually has some type of a CPU, a microcontroller, or a microprocessor there. There's an energy requirement. Everything needs energy, whether it's from batteries, solar, energy harvesting, or line powered. And then the next step is it has to be connected into the internet. And we move then from what we have body area networks, personal area networks, local area networks, and home area networks, and short range connectivity into some type of a gateway. I have a big long talk I could do just on gateways because this is often a hindrance to people getting out onto the internet. Then there's the wide area network after the gateway. Again, these can be wired or wireless. We're generally showing wireless here, but wired is still a very valid way to get onto the internet and sometimes the most reliable. And the whole purpose here is to get to the cloud. Now, the cloud can be many different things. The cloud can be just a repository for data so that it goes back again, or the cloud can actually be CPU intensive. There can be a lot of processing that happens in the cloud. And up in the cloud, we have applications that can run, as I mentioned, with the processing, actions that need to be performed, or you can collect data. And this is where some of the value comes with the cloud connectivity because data becomes, adds value. There's some monetary value to doing the data analytics. That's how Google is as wealthy as it is. But we're also seeing some really cool stuff happening, and this is where I look a little bit to the sort of from the present to the future. We're not seeing it so much in Canada, but a good example right now is voice-activated intelligence and control is becoming huge in the world. In the US, so everybody knows the Apple Siri application, where you can say, Siri, I want to do this or that, or Siri, what's the population of Montreal, stuff like that. But now it's getting more involved. So in the States, and you can buy this in Canada too, there's this little speaker that you can get that's deployed by Amazon, and it's called Alexa. And Alexa now gives you access up into this application and action space so that you can give it commands. It goes up to Amazon's services. It then can do things like send information back to your home, and you can say, Alexa, turn on my lights. And in your room, your lights will turn on if you've got connected lights. And this is pushing forward a lot of the home automation stuff that was out there for, say, the last 10 years, but it's really starting to take off now that the user interface is becoming easier. Everybody said, well, I can just connect to the lights through my phone, through Bluetooth or Wi-Fi, and I can turn them off and change the colors or whatever. But the voice activation is becoming that next little thing that's pushing it beyond the simple phone application. Now you don't have, it's all hands-free. It's much easier than using a light switch because you can just use your voice, which you carry with you all the time. So this is quite interesting. And so, this is, again, it's just another slide showing the types of things that we start from the edge nodes with motor control, real-time processing, sensors and management, metrology algorithms for measuring energy, things like that, a nice fail-proof user interface and battery-powered. And this is where the embedded developers work. This is where a lot of the IoT people are. But then they need to think about, okay, so now I need an API that gets me into the cloud. We have all these different network services. Security. Security is something which is fundamental to everything that you do in the IoT space. If you leave out security, you have left out part of the IoT. And this is becoming more and more prevalent as time goes on. The bad press that companies are getting for failed security systems it can kill a company. So this is very critical. Low power is important. Lots of integration because small and compact is important. Getting out there quickly without having to develop boards like this from the ground up is important. So this is actually a module that Microchip sells, and now you can buy this all ready to go. It's got a microcontroller, it's got a Wi-Fi device in it, and basically it's an IoT node all on its own. All you really need to do is give it power, and you can configure the software to where you want it. And now this gets you up into the cloud where you can confirm identities and govern what's going on. You can route data. You can get to the data centers. You can offer this business intelligence that people are looking for. Many different events can be processed. Dealing with the enterprise and all of these back-end services that the other side of the IoT needs to deal with, the back-end service developers. And this may be subscribing to a partnership with somebody else, the Amazon Web Services of the world, the Microsoft Azure cloud, and so on. There's many different ways to do this, and I'll show you some of the partners that we particularly work with. So, as an IoT node, what's the process? Well, you have to break it down. At the edge of the node, you say, okay, what's the data that I'm interested in? Is this am I acquiring data, or am I making demands on what the edge node is going to do? Then you have to think, what's the computation level? How much intelligence does this need? Do I need to manage all the data that I'm receiving or sending, and I have to intelligently communicate this. Reducing the payload that you have to send across the internet is always a valuable thing to do. And so you have to make that decision. Do I want distributed processing, or do I want to process it locally right at the edge? Connectivity, always a big question. Do I want wired, wireless, both? And then there's many different options you have for all of those. And as I mentioned, security is fundamental for when you break down your IoT application. Security means that you must make sure that anything you deliver or receive is integral. It's got its own integrity. You have to know that the data that was sent is actually what you received. And it has to be authentic. You have to know that the data that you are sending or receiving actually is going to the right person or has come from the right place. There's the man-in-the-middle issues or the spoofing that happens, and that's a very critical thing. And confidentiality is an option. So sometimes the data you're sending may not be critical. So what if your temperature is confidential or not for a thermostat, for example? But you have to know that the temperature you've sent is actually authentic and it's got its integrity. So confidentiality is an option, but often it can be part of the security as well, because it may be, say, private information or personal information that must maintain its privacy. When we talk about the date of interest, so again, send or receive, what are the time constants? Do I have something that I can send now and receive it an hour from now, or do I need it within a microsecond? So that determines a lot of what your IoT device looks like. And what are the peak rates? What's the maximum data rate that I have to send through? Am I sending through video that I have to receive in real time, or am I sending temperature, which can be, I can receive it within 30 seconds and everything's cool. Quantity, and how much data do I have? Do I want to store this locally, or am I always going to pass it through? So do I need some local storage? I mentioned privacy. Is there a private element to the data? And lastly, does this have to follow a standard? Is there a standard for this data of interest? Is there a particular format that the world is expecting in standards? And is that standard evolving? Do I want to use today's standard or the evolving standard? And these become big questions. On the computation and control side, then let's, again, think about bandwidth. How much computation do I want? Am I doing gigaflops, as what we talked about in the last presentation for intelligent cars, or do I just have a small amount of computation to do? What's the data dependence on time and latency, the amount, the quantity and peak rates, all of the things I talked about in the last slide. And then peripheral devices. How many things do connect to my edge node? Like, are there other devices that have to plug into it? Do I have USB? Do I have Bluetooth things that add on to what I'm doing? And then, of course, memory and all the interfaces that are related to those. On the connectivity side, again, wired or wireless. This is always a question. Most people today seem to want to go wireless. That's the interest of where people want to go. That's the nothing to plug in idea is the ideal, it seems. Do I need to follow standards? What is the standard in the industry that I'm pursuing? Or do I have to deal with multi-standards? Do I need to have a Wi-Fi and a Bluetooth connection? And then related to all these, how much power does this require? Bluetooth low energy requires far less energy than Wi-Fi does. So this can be your decision factor. If I go wired, then again, there's many different standards to pick from, or can I do a proprietary one? And wireless, as I mentioned, so the most popular today are Wi-Fi, Bluetooth, Zigbee, but we're starting to see some evolution towards some sub-gigahertz interfaces as well. Things like LoRa and Sigfox run on sub-gigahertz networks. So because we can get much greater range, we get wall penetration and that type of thing. So on the engineering side, for a startup, the design is the fun part. Coming up with concepts and prototypes and example gadgets, that's the fun part for the startups. Then they have to move on to what I call the real engineering. So now you have to start doing verification. How robust is my design? Does it meet a spec? Did I have a spec? Is it interoperability? If I'm following a standard, it has to work with other devices. If it's connected to a cell phone, how many cell phone models does it work with? Oh, the iPhone 7 just came up. Guess what? It doesn't work. So, you know, there's all kinds of things they have to look at. Qualification. So if it's following a standard, do I have to qualify it with other devices? You know, do I have a plan for how it's qualified so that I can say this is production ready? And then certifications. If it's following a standard, if it's wireless, there's always a certification involved. Is there CSA or UL approvals that need to be done? All of these things, and these are new to startups. So this is where the incubators and the accelerators help them move along to this path, because this is all new to them. Or they go to third parties. The CIMEQs of the world can help them with the experience of this. In Montreal, we have Wi-Fi certification or wireless certification houses. They can help with Industry Canada and FCC certification. The new RED certifications required for Europe. And then we have to deal with all the little ones like Australia in Asia and all the others. So it's quite a process, and that can take months. It also means funding. And then production. So this is the hard part. This is something that startups generally know nothing about. So taking a device to production, produce it in mass quantities, make it testable. These are a lot of the challenges that the startups see. And so, you know, Microchip, the company I work for, you know, we try to bring all of this together. So there's the industrial design and design partners that we have. You can go, you know, we work with companies. When I'm talking to engineers, they ask me questions. They're often looking for partners that can help them along certain paths. And then, you know, there's the incubators, accelerators, and workspaces where they can actually find some of this information as well to help them move along. So they can take this monumentous task of developing a product and actually get it to the marketplace. And so as a startup, you know, you have to use your resources. So, you know, we look at the incubators and accelerators dealing with all these different startups. We have industrial design firms too that help with, you know, the feasibility, IP research, figuring out a process for design, the mechanical engineering and industrial design. All of this is helped by the design firms. And then in this whole chain, another thing to think about is, you know, from a hardware perspective, the distributors in the semiconductor space can be very helpful as well. I'm not a distributor. I'm the microchip. We're the semiconductor manufacturer. So the distributors can play a role as well. They can offer complementary technology. So a designer who's looking at you know, they've chosen wireless. Well, the distributor could also say, well, I've got a power supply solution for you, and that's a simplistic example, but that's what they can do. They're also starting to help with some seed funding to help companies move that little extra step, almost like the accelerator incubator role. They can offer other services like kitting, you know, putting all your parts together, that whole bundle of stuff that you have to actually build your product. And then the logistics of delivering this on time, helping to set, you know, where they get delivered and all the logistics of the supply chain for that product. And then, you know, the OEM, the semiconductor vendor like Microchip, you know, we have in-house the embedded expertise to help engineers along with their designs. That we're providing the continuous reinvestment into our products so that the IoT startups and the IoT world can design their next product. We're leading with the technology that can help them move forward. We have our we have our finger on the pulse of what's going on in the marketplace, so we're developing new products all the time with significant R&D dollars to help move things forward. And we have world-class partners in terms of design houses that can help move people, including some of the cloud space providers. And in the end, you end up with a total solution. The idea is to get you to revenue more quickly, lower your development costs, and of course, reduce the risk of going in that direction. So, our value proposition is we've got the high performance microcontrollers, digital signal controllers, and the microprocessors that become the brain of the IoT device. There's also what people don't think of microchip typically of as having large portfolio of analog and mixed signal devices. In fact, it's a very large portion of our business is all the analog that we are offering that complement the microcontroller and the microprocessors. And all the interface and security solutions. Security is a big space for us. That came through, a lot of it came through the Atmel acquisition, and we're very much partnered in terms of delivering very close to turnkey security solutions for people that want to get involved with an IoT solution. Clock and timing, there's always a clock in anything digital, so we have some great parts for this. We work both with wired and wireless devices and offer support stacks and other things that go along with that. Pretty much anything with a computer on it has to have some form of memory, so we have a large portfolio of memories. Our software libraries help to move these designs along because anything with a brain in it, a microcontroller, has some software that goes along with it in order to get onto the internet. And as I mentioned, cloud partnership. We have a very strong and very successful relationship with Amazon Web Services, so we have some very cool things out there. If you do some searches on the internet, you'll find there's a little gadget called an Amazon button, and it's a very simple little device. It connects by Wi-Fi, and it costs $5 from Amazon, and it's got a logo of a brand on it. Say, for example, I think I've seen one, it says Tide on it. And you put that, you stick it on your washing machine, and whenever you run out of Tide, you press the button and it orders it a $5 discount coupon. And all very closely with them for security. So they've implemented a very strong security system where it's mutual authentication that happens in both directions with an AWS connection. So this is very interesting for the cloud. One of the big challenges is authenticating devices over the internet. So these are the kinds of things. We're working strongly with Microsoft Azure as well. And I think I've got a list of some of the other partnerships we have here. So, this is the kind of the complete solution that we offer. So, central to at the beginning was always the microcontroller and microprocessor, but now look at all the other things that surround a complete solution. And these are all very important things. We work in all of these areas with transceivers and memories and sensors, amplifiers, high voltage, and all the wireless standards. Here's an example of a bunch of devices that we have central to a microprocessor that runs Linux. You'll notice things like this are showing up now too. So ARM has something called Trustzone, which is a very highly secure environment that you can run a trusted environment for the very secure part of your application, and then the rest of Linux runs outside of that. So you can keep a very small secure element and then run the standard Linux kernel outside of it. So it's a very interesting way to deploy devices, again, with a focus on making sure that security, that Linux can actually crash in the system, but this trusted environment stays running. So you can actually reboot Linux safely and securely. It's a very interesting way to handle things. And then, crypto memories, all the connectivity and memory connections above it. So, the other value we add in terms of value is obviously tools and guidance to young engineers or companies working. We have the partners and distribution partners in the cloud space. many application notes, reference designs. No engineer starts from the ground and says, I'm going to take this controller and I'm going to start writing code from my main line. All engineers today want to start with some baseline code that's provided by somebody else. They want to load a Linux kernel. They don't want to write a driver for anything. They want the drivers there for Ethernet, for Wi-Fi, and so on. So it's more of a block level design, not from the ground up. Very few engineers are doing that anymore. So that's why reference designs and all this code base comes in. And this large sales and applications team, we actually have at Microchip more applications engineers than we do salespeople, because that's the evolution of this business, is that the application space is becoming so important. And of course, local people like myself, I'm in Montreal at least every 2 weeks, sometimes more. And we have remote support as well. So we've got support worldwide. Microchip is a non-commissioned sales force. So that means that if you've got a design that's distributed throughout the world, you can get Microchip support from anybody and nobody's going to complain because they're not getting paid a commission or something like that. And then 24-hour support. So again, we have hotlines and email support. So we can offer support to people all over the place. So this shows you kind of our support centers around the world. And we're the only non-commissioned sales force in the semiconductor space. And this helps us to do this more effectively. And to show you also just how things are growing, the semiconductor world is shrinking in terms of the number of players. Everybody's buying everybody. It's like I used to talk about telecom 20 years ago. So as you see, Atmel disappears off this list because now we're Microchip, and this is where we're going in terms of the world microcontroller market share. So now we're in the top 3, and hopefully this changes even more so in the coming years. So this is quite interesting, and as what was attested to earlier today, in terms of the number of chips being supplied and the cost of semiconductors, like it's got down to such a low point now that we're seeing prices kind of flatten out, but the volumes we're shipping is just it's unbelievable what we're producing every day. We're shipping millions of devices every day, and if you just think about the manufacturing logistics of that, even as I said to somebody earlier, just putting that many parts in boxes every day is a challenge, let alone making them, testing them, and adjusting the supply to what the demand is. Just to highlight too, our analog and interface products, we offer more than the microcontroller, all of these different types of products. And you can go on our website, find exactly this slide, you click on it, and it will actually help you drill down to find the device you want. So we're offering tools not only to work with our devices, but to find them, because finding with all the variety of devices and different demands people have, it's just a challenge to source what you need for your particular problem. So so our solutions basically is relentless on innovation, better, faster, smaller, lower power, lower cost, higher analog content, and increased integration. It's key to what we're doing. To make development and manufacturing more easy, we have very low-cost programmable solutions. We have modules that are pre-certified, so you don't have to go through that whole step. And for the Internet of Things, the idea is to distribute that intelligence because it's spread out through this whole Internet of Things. So we have all these different connectivity solutions, so you can spread that out to all your end devices. And of course, energy efficient is key to most of these, because as an edge node, you're often not plugged into any wire anywhere, so the power has to come from a battery or some type of energy source other than a wire that you're plugged into. The other solutions we have, we've got intelligent sensors in terms of we can help with higher performance, nice small size, power, and even high temperature solutions where people put things in crazy hot places like in light fixtures and so on. Human interfaces is all important. The days of the switch are really reducing. If you think about the number of times people hit their phone screen these days, 20 years ago, those were all switches. And now that little keypad that you're running your thumbs over has replaced switches. So if you look at the number of phones in the world and the number of taps you see a day, those all used to be switches. So times have changed. Looking at proximity gestures, we can do 3D gestures. We can wave. We've got it in a car, so you can wave your hand and it'll advance the song and stuff like that. Audio and speech. I mentioned the Alexa and the similarly there's the Google Home application. So this is becoming more and more interesting. We'll probably see it in the car eventually. Small form factor packaging, everything very small. CSP is chip scale packaging. We're seeing more and more that I can show you the smallest Bluetooth devices in the world right now. They're in my bag if you can find them. So those are the things that we're all doing, and I welcome any questions, comments, and thank you for your time today. Yes?
I didn't know a microchip purchased Atmel, so
Yeah.
I wonder, are you going to keep the microcontroller PIC series and the Atmega series?
Absolutely.
Oh,
Yes.
okay,
Yeah.
so
In fact, we're growing them both.
oh yeah.
So our CEO has been very pleased with the acquisition of Atmel. They found some very nice technologies that they didn't even know they were buying. So they've actually increased the funding into some of our design pipes, and they actually added some. So for example, they're investing into the AVR heavily, whereas Atmel had not put a lot of investment into it over the last, say, 3 years, and now they've actually increased the amount of activity there. The microprocessor is new to Microchip, so there's been some heavy investment going into the microprocessor side with things like Cortex-A5 and some future devices. So there's some very interesting things going on. We're working towards, we're continuing to support there's been no obsolescence of devices. They'll support them both. And in fact, it's exciting for people like myself because now we can work with both the PIC and the AVR and the ARM devices and find out what works best for the customer. If they're very familiar with the PIC and the design flow with the PIC, then there's great devices there. If they were AVR users, the Arduino community, for example, for startups is huge. So we're continuing to support. In fact, we're promoting it further. And then ARM is, a lot of people have strategically chosen ARM in their design flow, so we continue to support that. And again, new products coming out all the time. It's a bigger, stronger Microchip. Yeah, the acquisition happened beginning of April in 2016, and so it's been a process for integrating teams and setting product directions. But that's basically done, and everything's moving forward.
Are you going to be here this afternoon?
Just for a little while, not too long.
Okay.
But yeah, feel free to pull me aside. Yep. Anybody else? All right, thank you. Enjoy your lunch today. Great.